Hello, welcome to Bedroom Builds at the From Python to Rust series, episode F, Debugging, continuing from the previous episode where we spoke about testing. Debugging can be done in a multitude of ways. A very common one is the print line debugging. Print line debugging basically means you're using, for example, the print line macro to print out to standard out the variables that you want to see to verify or find and narrow down the problem. This is very infamous, this technique, but very commonly used. With Rust, you can also use the Gnu Debugger or the LLVM debugger for your code, as it is a normal binary with all the binary meta information for debugging inside. This is easiest done in an IDE like Visual Studio Code or, well, your IDE of choice. Basically, using the actual debugger, I would suggest you try to not even have to do it, because given the episode that we're coming from, you have written your tests, so they will help you to narrow down the problem anyways, or maybe not even let you introduce a bug into your software. And usually much faster than using a debugger is to think about the problem or search on your favorite search engine for somebody else that had the same issue, and then you will likely find the solution much faster. For thinking, there is a cool story of a programmer that used to have a rubber duck with him. So when a colleague or he himself had an issue, he either made the colleague or himself explain the problem in the most simple terms possible to the rubber duck, which makes sense because the rubber duck has no clue about the computers or programming. So when you re-thought about your problem from the very basis and explained it to the duck, you usually found the bug. And this is a really good technique, actually, to really come from a different angle, or to simply take a break, do something else that is not involving this bug or this problem, and then come back to the issue sometime later. And then with this new, fresh mind of yours, you will actually quickly find the bug. Now let's hop over to the code and see how we can employ print line debugging. As we can see on the right, we have our FizzBuzz code, and it doesn't work right, because for the input of the number 1 here, we don't get the output expected. So up here we have our algorithm that would translate the incoming numbers into the respective strings. So if it's divisible by 3 and 5, we get FizzBuzz, and so on. And here we have a function that builds us a vector for the input. So for n, it would do a loop, and then it would push to the vector the output of our FizzBuzz function. And here the expected output would actually be, well, we at least want to see the number 1 coming out, but that's not happening. Let's verify that this is the case. And it's true, our vector stays empty. Now, in order to find out why that is, we can, of course, introduce some print line debugging. Now, we are here in this loop, and it's supposed to push inside the vector. So let's see if the push is happening. We could put like comments calling it push, and then maybe even we add the integer outputs so we see where we are in the loop. And when we try to run that, it still doesn't show us the print line, so we know we are not going into the loop. But why are we not going to the loop? This is very confusing. So let's print the end that's coming in. Maybe this is somehow wrong and it's not the 1 or something, because this is really strange. It should happen. And now we get an output, so the function itself is called. That's a good news. And the input is actually 1. However, this loop doesn't work. And now we have narrowed down the issue, so it must be in the definition of the loop. If we hop over to the code, we can see that we get to here, because this is printed out, but apparently this is not happening. So in this line of code, we must have an issue. So we can look into here. So what's happening on this line? We are doing a for loop where we start to count at 1, like humans do, up onto the number n. And this would go into our variable I that we can then use to push the fizzbuzz. And now in our plinter line debugging code also would write out where we are. But it's not happening. Why is that? Because we are counting from 1 to, if n is 1, 1. Therefore, this loop is never executed because the exit condition is true right away. This means we have to fix the code right here by adding +1 to n for this to work correctly. Let's do that actually. So we go here, +1, and when we run the code now, we actually get the output that we wanted. We see push 1, 1, 2 times because I was too lazy changing the text in our debug message, which is one of the disadvantages. Then also one of the disadvantages is if you get a bug reported that's supposed to be on a certain line number and you start introducing the print lines commands all over the place, you will actually change the line numbers in your code. That's a negative approach. However, there's a nice cool tool out there in Rust community that's not print line but the debug macro. Let's use the debug macro and see how this helps us doing what we want. So we can remove this one and this one, and with the debug macro we can actually write code like this: debug what the debug macro does is it takes the expression that's within the debug macro, in this case it's our fizzbuzz call, takes the output and prints it out with meta information to the screen, and also returns it so that it can be used as normally in the code. So in this case the push will work as it did before, but now we get extra output. Let's see what the consequences are of this one. So now we get our output with the meta information. So this will automatically generate which source code in which line, which call or which expression, and what does this generate? So a string with the content 1, and our vector pushing still works out. So these are the print line debugging options that you have in Rust. Fairly easy to use and powerful. Now, what you've realized while I was introducing the print line commands and then we found the issue here, the bug was narrowed down to the line with the print lines, but we didn't really debug it. It didn't help us really fix the bug. The actual debugging came when we thought about what is this line actually doing, which brings me to the last point I made at the first slide. Thinking about what you're doing and re-explaining it to yourself or to a rubber duck will help you fix the bug. And a debugger will not necessarily do more for you because it will also only show you which variables have which values and where you are in the code. So normally searching or thinking will lead you to a faster solution. Now I've prepared Visual Studio Code to do debugging. I normally don't do this much, but I have still done it. So this is here. We are in the code that we had prepared for our square area stuff. And the use of this is very easy to use. So here, when I hover over the line numbers, you see those red dots coming up. What I can do is, for example, go here and set a breakpoint. Now I can go here to the Run tab on the left and run debug unit tests. This will now run the application and it will stop right here. This means we can shrink this for the viewers and go up in the source code. So it stopped at our breakpoint that we set, and this means we can look into the environment and it will show us the local variables available are our circle with these attributes inside, and it will also show you global stuff and the status of the registers of your CPU and whatnot. So this hopefully helps you and is fairly easy to use. That's an option that I find much easier than to use the command line debuggers. If I ever have to debug, I try to find some graphical user interface that helps me. You can restart the application, step out, step in, and step over stuff. So if I now step over this breakpoint, the test will be finished. And you can also see here that left val, right val is now populated in the local variables. And now we are actually exiting. And now we are hopping into code of Rust itself. So let's stop the debugger. And this way you can debug in a graphical user interface. This was only a short introduction of what can be done and how it's possible. I hope this was helpful. Thanks for watching. Coming up next on the From Python to Rust series will be smart pointers.